Hello everybody, today we will move on to the next Christmas ornament in a more classical design. So I will show you how to do that in Grasshopper and what else you can do with the design. So just let's go. Alright, here we are again, back to business. So for this Christmas ornament we basically also rely on sphere. So let's start with this one. Create a spherical surface, we apply a radius, I don't know, or yeah, maybe 25. I'm not sure what we use for the last one. So we have a sphere where we want it. The next thing is that I want to split the sphere into 10 separate sections. So for that reason, I will construct a point and it automatically generates one in the origin. And I move this point according to a range. Okay, so now that we have a point, I want to multiply the point and I will use a range for that purpose. So range provides me with a list of values within a certain domain, equally distributed within that domain. So these are now 10 steps, every time 0.1 more. But I want a domain that is based on the radius. So I do construct domain. Then I can plug this one in here. And now I need, let's say, the minimum value of the range that we want to apply and the maximum value. And for this one here, I would say just negative our radius and positive our radius. And then we have values from minus 25 to 25, which is in line with the size of our sphere. So even if I change the dimensions now, it will always be more or less the same separation in the sections. Okay, how many steps? I mean, we can do whatever we want. Maybe at the beginning I try with 10 only to make it clear. And then we can still move on. And in order to apply that range to the move component, we have to convert it into a vector. And basically I just want to apply these in the z direction. And now I have my points distributed equally in height and they match the radius of my sphere. So what I do need next is a plane surface. So that basically creates a surface at a certain origin. So now I have basically at every point I create a new surface. I need it to be bigger in order to split the sphere, I think at least. And here I create the domain in a more simplified way. So I just type -100 to 100 and that basically defines now the size of my planes and they cross the sphere. So we say split brep multiple. So we have the brep sphere and I want to cut it with the planes. And now we see it's divided in multiple sections. Now I just want to try for myself if it also works with if the planes are smaller. So let's remove 1 0. So it doesn't, right, as expected. But good to check sometimes to be sure, because in some cases planes are defined as infinite, right? But these are surfaces that are planar, so they are not understood as infinite, which is why they have to basically be bigger than the geometry that we want to split with those curves or with those surfaces, right? Now we take the brep edges of our split and here now we have the ability to choose between different curves, and I'm interested in these ones, right? The different circles rather than the arc at the seam. So if you're uncertain which one it is, just take the list item and plug it in to see what kind of curves we have, and then soon you understand, okay, you need the naked edges. So now basically every section gives me like an upper curve and a lower curve, and the section below has an upper and lower curve, so there's many double curves also. So we will have to fix that either by removing the double ones, or we can also just say we use the list item, and now it will has automatically selected only the ones with the index 0, which in our case is also working, because then it only takes the next one, which is not a double. I think we still have some double, but we will fix it anyway later. Now what I want to do is basically I want to divide these curves, creating points along these curves. 10 points is fine for me at the moment. We can also make this a slider, so we can decide if we want more points or less. I don't know, maybe 12. And then I want to basically move every other point inwards. For that reason, I take the area which of these circles, which gives me the area, but most importantly the center point. So now I can scale along these centers with a factor, but I still have to make sure that I only take every other point and not every point, right? Because now if I take the points and I just scale all of them, that's not what I want to do. Instead, I use the dispatch. I plug the list in, and here what dispatch does is basically just create two lists from one based on a pattern, and the default pattern is true false. So every second index of your list will be dispatched into the second list. So now I can take, let's say, list B, and it will give me, let's say, only half of them. Every second point is now in my scaled list, and the other ones are as they were. And now we can weave them back together. So we take stream 0, nothing changed, and here we use the scaled ones, and now we already see that we have a change to our point distribution. And if we make this now a polyline, it becomes more visible. So we already get like this sort of star kind of vibe. And maybe you want them to be close. I think for this purpose, yeah, we need a Boolean toggle. Plug it in, say true, and now it closes the curves for us. And now I basically want to loft the curves, but we do still have to make some cleanup first. So let's flatten this whole thing. So again, what does flatten do? So now we have, let's say, every curve is in an individual branch, and we have a lot of branches because I never simplified any of the inputs. So we just keep on building and building. And in comparison, what I do with flatten is basically just put everything in one list, in one single branch. And depending on what you want to achieve, this can be a good thing or a bad thing. So you always have to be aware of the current data structure of your algorithm to make sure you can control it, because it still happens a lot to me, to be honest, that I do something and then I flatten, and then suddenly I have way too many geometries work with the component and it explodes because 10,000s of things suddenly are being calculated. So now we still have to do some cleanup, because 1, 2, 3, 4, 5, 6, 7, 8, 9. I see 9 curves, but it does have 10 values, so there's at least one double. But it's always good to do some cleanup anyway. So let's see which one it is. Which one is the double? So if we start at 0, 1, okay, that seems all good. Okay, 9 and 8 are the same. Okay, then we can use the cull index instead of the cull pattern. Plug the list and say this is supposed to be 9. And now we have a list with one value less and no doubles, right? But what I don't like about this approach, now it's a fixed index. So if we want to adjust, let's say, the number of steps in our range, basically fine tune, then we are forced to go back into our algorithm and change this. I would do instead a subtraction, and here I plug in 1. And in this guy, I take my step count, which basically defines how many curves we have, right? Because that basically is the setup for how many slices and surfaces we have. So that's why I take this value and I say if I remove 1 from this value, then I get basically the right index for the curve that I want to get rid of. And it works, and let's say we give it a try. So I don't know, 21, 20, whatever. So you see also the shape changes, it becomes a little bit more spherical. So in that way, I think it's an important slider, an important value to adjust, to be able to adjust. But here everything is still not falling apart. So now I want to rotate, or maybe we can already do a loft just to showcase, right, what we have. So we have a star. Now you can do what you want with it. Where here the factor, you can adjust the scale factor to make it more flat or more sharp. And as seen before, you can adjust these values to basically take bigger sections of the circle, of the sphere. Or obviously you could also just move up the second to last point in our point list here. But I just do it like this anyway for now. I don't mind. Alright, so this is the loft, but what I want to do now is I want to be able to rotate these different curves, so we get like a little bit more of a dynamic appearance. So in order to do that, I will create another range. So let's construct a domain. And then we say from 0. So basically, okay, maybe let's do it differently. Rotate. So I want to take these curves and I want to rotate them. And I go right click here and say degrees, because otherwise it's in polar coordinates. And we want them to just provide the degree rotation. And it already has a preset value here, but we will overwrite it. But basically, if you put in a slider, let's do this one. probably a little bit too much, but okay. Plug it in, and then you see that we have the control of the rotation of our curves. But now they rotate all at once. And what I want to do instead is rotate them bit by bit. So we get like a curve instead of a straight line connection between. So let's see if we start this one here and this one here, and we have now 11, 17. How many steps? So we need to make sure that we have the right amount of steps. All right, so here we have 17 values. So we need basically 16 steps in order to get 17 values out of our range. So we have an according number, right? So what's the result here? 17. So I basically do the same thing again. It's already here, why not? Opa. So I basically take the 17 and I subtract another one, and then I get 16, and then I have a range that gives me 17 values, which is in line with the number of values that I have from my list anyway. I plug that. Oh no, it's already plugged. So exactly, now I have the correct range, and now these are my values. So the rotation is happening for different curves independently, right? So much more rotation at the bottom than we would have at the top. Maybe we do increase, so we can see a little bit more the effect that it could generate, right? So we get this swirly vibe. And now we can just plug these curves in, and you see what we get. And now we can write a nice and uniform rotation, which is because it's based on the range and nothing else. And then you can cap holes, because now we still have holes at the top. And now it's a closed one, and then you can bake it. So feel free to play around with your design. I don't know, maybe that's the one you like. You can look at it again in the rendered style, but maybe it's too extreme also. So let's say I want this to be a little bit more flat. Maybe give this a little bit more space to have some more fine tuning here. So it's a little bit less extreme. And we divide the curve now into higher numbers, right? And now you can basically adjust the number of the stars that you have. And then you get more of something like this. I think this is really interesting. And again, if we adjust this number, then we basically reach closer to the top. But we also make the whole algorithm much more heavy. So be careful and cautious about this. And now we still can adjust our rotation. We can even go more extreme. Right, so we have this funny, funky geometry, but if you want to print this, it might be difficult because you need support, and then you basically have to close all these gaps if you use a regular printer. But with angles like this, I think you're still good to go. And then again, we bake this, and we have a pretty cool classical design Christmas ornament that we can basically adjust however we like and do cool decorative stuff with it. That was the tutorial for creating this classical design Christmas ornament. Thank you for watching.